In physics, there are many forces. As we know, any time that two objects make contact, there is a force. We also know about 3 common field forces, and we know that technically there are 5 field forces. We're going to focus on some of these contact forces today and one of the field forces as we learn about some common forces that we'll see in our study of kinematics. The first of these common forces is something called the gravitational force. Now, in common terms, we call the gravitational force something different. In our everyday language, we commonly refer to gravitational force as an object's weight. So when you hear weight, we're really talking about the force that the Earth exerts on an object. Remember that weight is something very different from mass. If you go to the moon, your weight would most definitely change, but your mass would not. Now, we commonly think of weight as being something that the Earth is exerting on you, but really the gravitational force is a force that one mass exerts on another mass. So any 2 objects with mass could exert a gravitational force on each other. For the purposes of our class, for the most part, one of those masses will be the Earth. So we'll be focusing on the gravitational force that the Earth exerts on an object. As we learn each force, we're also going to learn about each force's direction. Now, we know that if we're thinking about Earth, we are attracted to Earth. That means we feel a force toward the Earth. And that counts for the force in general. The direction of gravitational force is always toward the other mass. We'll also learn a symbol and an equation for our forces as we learn them. The symbol for gravitational force is a capital F with a lowercase g as a subscript. And we have a special equation that we can use to calculate gravitational force. When we're on Earth, the gravitational force is equal to mass times the gravitational acceleration. We know that to be 9.8 meters per second squared. We could also put a vector symbol on top of force and gravitational acceleration, showing that the gravitational force is always in the same direction as the gravitational acceleration. Moving on to another common force. Another one is something called the normal force. Now in physics, the term normal doesn't refer to ordinary. Rather, it refers to the term perpendicular. The normal force is a force that any surface would exert on a mass. So if you think of standing on a floor, that floor would be the surface, exerting a normal force on you. Or perhaps you have a pen sitting on your table. The table would be exerting the normal force on the pen. I mentioned that normal in math or in physics refers to the term perpendicular. The name of normal force comes from its direction. It is always perpendicular to the surface and pointed away from the surface toward the object. Normal force does have its own special symbol. Just like gravitational force, normal force will have a capital F, but this time it is a lowercase capital N. Now, depending what resource you look at, some textbooks or some websites may just simply use a capital letter N as the symbol for normal force. I find this can get a little bit confusing because it's easy to confuse it with the symbol for Newton, which is also a capital N. Moving on to another force. Next is tension. Tension, again, has a different meaning in physics than it maybe does in your everyday life. Tension is a force that a rope or string or chain or anything flexible like that would exert on a mass. the direction of tension is always along the rope or string or chain or anything like that, pointed away from the object. As far as the symbol goes for tension we'll just use a capital T. Again, some resources or textbooks may use a capital F with a subscript of a capital T. Our last common force that we'll deal with is the force of friction. Friction's a force that we know, it's a pretty common term. It refers to the force that resists motion, or, I have in quotes, the desire to move. In other words, if you just have an object sitting on a flat surface, no friction is present. However, as soon as you have some other force applied to that object, you could potentially have friction. The direction of friction is always opposite that of motion, or opposite the direction an object would move if friction weren't present. And our last couple of facts here. The symbol for friction is a lowercase script f. Let's see if I can make that look kind of scripty here with typing. We'll talk later on about the fact that there are actually two types of friction. And we'll also learn some equations for friction later on in the chapter. So these four forces are ones that will commonly appear in problems that we'll use. And these four forces are ones that you should be able to recognize as we talk about situations and where forces are being applied.